Good afternoon. First of all, I would like to thank the organizing committee for giving the opportunity to participate in this workshop and talk about validation and uncertainty estimation of HPLC method combined with ultrasound-assisted extraction procedure for quantitative determination of hesperidin obtained from citrus peel. So, the present research was carried out within 3-year scientific project supported by Shotaro Staveli National Science Foundation, aimed to develop laboratory technologies for utilization of different types of agro-industrial waste materials. This is a new and alternative technology based on the principle that one waste can be used to obtain several valuable bioactive product in the same stepwise extraction process, and which provides to remain less amount of byproduct processing wastes. In support of this technology, different new analytical methods were developed and validated, and this is one of the developed and validated method I'm talking about now. Research goal was to validate a new method obtained with a combination of two procedures. This is sequential two-step extraction procedure using ultrasound-assisted techniques for obtaining hesperidin from citrus peel, and second procedure, analytical HPLC procedure for quantitative determination of hesperidin is obtained dry extracted product and citrus peel. And second goal was to estimate measurement uncertainty of the combined method based on the validation study. As is well known, hesperidin is a major bioflavonoid found in citrus fruits. Hesperidin exhibits many biological and pharmacological properties listed in this slide. This compound is a great demand around the world and used in the large quantities in pharmaceutical industry. During citrus byproduct processing, citrus waste is generated. It counts about half of the fruit weight and contains more than 70% of citrus peel. We used this raw material, tangerine peel, provided with a local juice and jam manufacturer, and to obtain 4 bioactive products by using the mentioned laboratory technologies. So the proposed method involves multiple steps, including sequential two-step extraction, cleanup, isolation, separation, and HPLC analysis. So I would like to represent this method as a flow chart on the slide. At the first stage, in order to prepare sample of tangerine peel, was dried at 40 degrees Celsius for 6 hours, then grinded manually to powder and weighted for about 20 grams. And the process is continued with 2-step extraction procedure. At the first stage of extraction, a steam distillation was performed to obtain essential oil. Then after centrifugation, the remaining residue was washed with a hot acidified water to isolate pectin and started ultrasound-assisted extraction to obtain carotenoids and asparagine. This extraction was carried out by ultrasound power 25 kilohertz and at 30 degrees Celsius. Ethanol was used as an extraction solvent. After ultrasonication, the obtained residue was filtered and evaporated by a rotary evaporator to obtain a syrup. This obtained syrup was diluted with acetic acid solution and allowed to stand for 6 hours under refrigeration in order to crystallize hesperidin. Then it was diluted with a purified water, heated at 70 degrees Celsius for 45 minutes. Then washed twice, step by step, isopropanol and chloroform, then filtered and dried at 40 degrees Celsius in thermostat. The obtained filtrate portions were collected and used to obtain beta-carotene by further procedure. They obtained dried extract product. Hesperidin was weighted and stored in vial. Then it was used to prepare test solution for HPLC analysis. We used analytical standard of hesperidin and a mixture of DMSO and methanol 1:9 ratio as a diluent, and the external standard method was used for quantification of the analyte, and the chromatographic condition are given on this slide. The proposed combined method was validated in the respect with all the validation parameters listed in the slide, such as robustness, specificity, linearity range, accuracy, sensitivity, limit of detection and limit of quantification, precision, system suitability test. And let's start to talk about the results of each validation parameter study. The first is system suitability test, checked by using standard solution of hesperidin with 6 replicate injections and evaluating the following parameters: column efficiency, symmetry, arrest of peak areas, and retention times obtained with the standard solution chromatogram. The results show on this slide the method completely meets the requirement of SST. And second parameter was specificity, which was checked using standard background control blank and test solution. In this slide, you can see the chromatograph spectra obtained with the standard solution. The principal peak is maximum absorbance about 280 nanometers in the UV spectra. And there are the chromatograms and spectra obtained with blank and test solutions, which show that no interference is observed, and the hesperidin peak is poor. On the UV spectra of blank solution, here is not observed any absorbance. Also, the percentage difference between retention times of hesperidin on the standard test solutions is not more than 1%. There is not observed any peak and UV absorbance at the retention time of the principal peak. Within the specificity test, forced degradation of hesperidin was investigated. Samples were treated under stress condition, alkali, acid, oxidative, UV radiation, and thermal degradation were performed. After that, sample preparation was carried out with the same manner as the test solutions preparation, and degraded hesperidin was evaluated by the percentage differences compared to the concentration of hesperidin in the test solution in normal condition, prepared in normal condition. The largest amount of hesperidin, approximately 90%, was degraded under oxidative conditions by hydrogen peroxide. The obtained results demonstrate that peak of hesperidin is poor in all cases, and thus confirming the absence of other peak in the same retention time. The principal peak is clearly separated from any secondary peak, and there is no interference. Hence, we have to conclude that the method is specific. In order to study linearity and the working concentration range, the working standard solution we are prepared at 11 different concentration levels. The concentration range was from 0.00025 milligram per milliliter from 0.5 milligram per milliliter. The plot calibration curve linearity graph is linear. The square of correlation coefficient, RSD of peak areas and retention times on each concentration level were calculated, and the results are within the acceptance criteria. Sensitivity was checked to be established limit of quantitation and the limit of detection, limit of quantitation was achieved by injecting a series of stepwise dilute working standard solution, and the values of Leo Q and Leo D are given in this table. There's a signal to noise ratio of RSD of peak areas for limit of quantitation were calculated as well. And the next parameter was precision of the method, which was estimated by measuring repeatability. This is intraday precision and time-dependent intermediate precision. This interday precision on 6 replicate injection of standard solution and 6 individual determination of hesperidin in test solution at 100% concentration. They calculate RSD of peak areas and retention times of standard solutions, RSD of 6 individual determination of hesperidin for both precision test, repeatability and intermediate, RSD of 12 individual determination, totally 6 samples plus 6 samples of intermediate precision, and the percentage differences, and so if test between both precision results comply with acceptance criteria. All the obtained results are given in this these tables. And the next parameter was accuracy. Accuracy of the method was assessed by performing recovery studies using standard addition method by spiking the known amounts at 100% of standard solution of three individual determination and 3 replicate injections. The similarity of 2 standard solutions were checked as well, and in order to prepare the spike test solutions, we have taken about 200 milligram of citrus peel, tangerine peel, and was mixed with 14 grams of the sample of dry tangerine peel. Then the sample preparation was carried out with the same manner as the test solution preparation, and the recovery of the method is acceptable, and they obtained the result confirmed that this method has a good accuracy. And now regarding robustness test for this parameter, both qualitative and quantitative critical parameters of the method were assessed and selected using risk assessment approach. Each working parameter was considered as a factor affected on the result of analysis and evaluated by 3 risk parameters: risk severity, risk probability, risk detectability, and 3 risk parameters. We evaluated 3 point scale, then we calculated risk level and defined risk category of each factor, and all the factors we are grouped into critical, significant, and negligible categories. The risk assessment matrix is given in this table. Each parameter, procedure, its character, risk parameters, risk category, and critical parameters. Some critical parameters were checked with other validation parameters, such as filter compatibility test and intermediate precision, for example, station phase of column. And based on the risk assessment. It has been established 11 critical parameters with 2 levels, plus and minus of the nominal values named 0 level or nominal condition. They are listed in the table, and all the critical parameters with 2 levels involved in 12 run experiments, which was designed according to the plaque environment design approach. And design of 12 run experiments is given in the table. Is 1 experiment, each critical parameters, as I mentioned, has 2 levels, plus and minus value, the concentration of hesperidin in test solution and SST parameters, coefficient, symmetry, RST peak areas, and peak retention times were used as a responsible variables for the method. The variation of each response variable and the modality of the obtained data were evaluated, and the obtained results given in this table show that none of the examined factors had an important effect on the result. They established variability of system suitability test parameters is acceptable and comply with the requirement of this parameter. The absolute difference between the maximal and minimal values of the determined concentration of hesperidin in test solution equals to 0.058 milligram per milliliter, which is very close, almost the same to the value of the precision. This equals to 0.064 milligram milliliter. The percentage differences between the precision for 12 determination and the robustness also for 12 determination, average results is 5.73%, which is not more than acceptance criteria of the precision parameter of the method, not less than 15%. And based on the analytical data obtained with the precision and robustness parameters, a histogram was plotted to indicate the distribution of variable values. Totally for 24 results. There is a multi-model data distribution, which showed the analytical data are collected from more than one procedure and condition. The results experimentally confirm the existence of several critical factors and the complexity of the method. Also the established variability is not going out of acceptable limits. The analytical data varies typically from 0.211 milligram per milliliter to 0.281 milligram per milliliter. And within the robustness test, test standards, the solution stability and filter compatibility we are investigated. Standard solution are stable within 7 days, protected sunlight and stored under refrigeration. Both type of filters, PVDF and MCE filters used in extraction and HPLC analysis are compatible. No adsorption of analyte on the filter and no effect on the result of analysis. And hence they obtained result of study of the critical factors effect, standard solution stability and filter compatibility test confirm that the method has a good robustness. And now let's start to talk about measurement uncertainty of the method. The process of measurement uncertainty evaluation was performed in 4 steps. At first step, the measurement was identified. At the next step, uncertainty contributors and sources were identified by Ishikawa diagram. At the third step, the quantification of uncertainty was performed by a combination of bottom-up and top-down approaches. The standard uncertainty arising from each individual source was evaluated by replicate measurements and method performance data based on the validation study. At the last step, the combined standard and expanded uncertainties were calculated. And this is cause and effect Ishikawa diagram, which indicates all the contributors affecting the measurement. This is the content, as I mentioned, of hesperidin in the tangerine peel, in the tangerine peel expressed milligram per gram, which was calculated by the formula shown on this slide. With the diagram, all contributors were grouped in 6 sources. Concentration of hesperidin in standard solution, accuracy of the method, repeatability of the method, concentration of hesperidin in intestinal solution, mass of citrus peel, obtained extract product, and analytical equipment HPLC system. And the table shows a budget of 5 uncertainty contributors from standard preparation. Each uncertainty values were used to calculate the combined relative standard uncertainty. The values is highlighted in red ring. And next table shows a budget of 5 uncertainty contributors from next source test preparation. It was calculated combined relative standard uncertainty, and this table shows the budget of 2 uncertainty contributors for mass of sample of tangerine peel and the obtained dry extract product. And the last table shows the budget of 4 uncertainty contributors from accuracy, repeatability of the method, and the HPLC measurement. Totally 17 contributors have been identified and estimated. Each contributor was calculated by the indicated formula in these tables, and the values of uncertainty originated from a sample and standard preparation were very small. Very small, because it contains only standard purity, molar mass, weighing, and volume measurements. But the contributors of accuracy and repeatability gives a large contribution to combined uncertainty in the method, which is caused by the complexity of the method containing multiple steps. In order to calculate an expanded uncertainty, coverage factor approximately 2 equals 2 was used as a multiplier of the combined standards uncertainty at the level of confidence over 95% for normal distribution data. Sorry. Normal distribution when distribution was checked by calculating the criteria. Their results of analysis of the extracted product and the tangerine peel, the average result was reported with expanded uncertainty value. The average content of hesperidin is 5.36 milligram per 1 gram of tangerine peel, and the purity of the extended product was about 90%. Based on the results, we can conclude that the obtained extracted product is chemically poor and high quality. Conclusions. In conclusion, the developed method obtained with a combination to stage.
Sorry, Imeda, we don't have time,
okay.
and please.
Okay, and finished. And the research was published in the monograph articles awarded with the academic prize from National Academy of Science of Georgia. And thank you for your attention.
Thank you.